Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Imran, BRCD AE190011. Uh, I'm from Group 6, Section 2, and the others member is Muhammad Ali bin Zahiruddin and then Muhammad Syahmi bin Muhammad Zainuddin. We are from FKEE faculty, and then right now we're going to electrical engineering from course BEV 20501 electrical engineering laboratory 1. So our presentation is about to measurement using the DC bridges. Next, I introduce to you the resistance measurement using DC bridges, which is accurate. Measurement of resistance may be performed by using impedance measuring bridges. There are usually many bridges identified by inventor's name to measure different type of resistance and impedance. The basic impedance bridge shown in this figure, which include AC supply, resistor, and diode. Now, this is the equation to the voltage of nodes A and B, and then the unknown impedance is Z4 equal to Z2 per Z1, Z3. And then to measure the real impedance or impedance resistor known as Wheatstone bridge to measure capacitance, inductance, or copper impedance, at least one of the Z1, Z2, Z3 must be complex to satisfy the balance equation, because if the total of the Z equal to 0, it means that it will balance the circuit. And then the resistance measurement is in Wheatstone bridge, which is the basic bridge circuit, is to measure medium branch resistance. DC voltage source and DC meter may use in the impedance to be is for it. And then the Wheatstone bridge circuit shows in the figure 5.2. This is R1, R2, R3 is the resistor, and then the R3 is the variable resistor. So find the unknown resistor is to use this equation. And then the resistor measurement using the Kelvin double bridges, which is modification of the Wheatstone bridge. They provide greatly increased accuracy because the low value resistance below 1 ohm. Then this show the Kelvin double bridge circuit. The term double bridge is used because the circuit contains a second set of resistive arms. The unknown resistors is as follow of this equation, and then for this experiment purpose is to determine the resistor measurement using Wheatstone bridge and the unknown resistor using the Kelvin double bridge. The objective is the student should be able to knowledge verify resistor measurement technique using Wheatstone bridge and Kelvin double bridge. Determine unknown resistance using Wheatstone bridge and Kelvin double bridge in simulation. Compare between resistor measurement between Wheatstone bridge and Kelvin double bridge. Experiment procedure. The details can be looked at the soft copy of the lab reports. This is the result. And this is the answer for the questions in the activity 3. Thanks. I will give to the next presenter.
Assalamualaikum. My name is Muhammad Syahmi bin Muhammad Zainuddin. I'm representing from Group 6 to explain about Activity 1, which uh, is to determining resistor measurement using Wheatstone bridge. So this is the simulation, and this is the circuit that I prepared beforehand. So to cut some time, So let's get into it. So this I'm using a VC. I mean DC circuit, DC source, which is the value is 10 volt, and we have four resistor, and one of them, which is R3, is variable resistor. So for the resistor number one, I'm using 10 kilo ohm. Resistor number two, I'm using 2 kilo ohm, 2.2 kilo ohm, sorry. And resistor number three, which is the variable resistor, I'm using 30 kilo ohm, which is the max. And then after that, for R4, I'm using 5.6 kilo ohm, and this is the ground. So after we connect all the resistor and to the ground, we start the simulation. So after we start the simulation, we can press here to adjust the percentage. So we have to adjust until the value of emitter close to zero or zero. So by adjusting it for about, so we are closing to zero but not quite. So yeah, okay. So we are very close. So I have to use this. So this the close one to zero is 402.14 nano kilo ohm. I mean nano ohm. This is the close that I can get to zero. So that's all for me for the activity one simulation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Zahir. So today I will present about activity 3 in lab exercise 5. So this is the procedure. Procedure 1 until procedure 12. So for procedure 1 until procedure 11, we need to set the switch S to bridge mode, switch K to open mode, and emitter reading to ampere rheostat 6 ohm. So this is the simulation. So we need to set the switch S into bridge mode and switch K into open mode. So this is resistor 1000, the volt is 12, and the current is 2 ampere. Okay, so so this is the millivoltmeter that we get, which is 0 volt. So uh, okay, next we need to change the switch K into closed mode. Then we get the millivoltmeter, which is negative 0.0989. So we need to make sure this millivoltmeter 0 volt. So we need to change the resistor here, the two resistor here. So the first resistor we get 976.8. So here we need to change 976. Okay. So for the second resistor 994.3. So here 994.3. Okay. So when we change the resistor, we get the 0 volt for the millivoltmeter. Okay, so for step 12, we need to repeat the procedure of visual lab for low resistance S between 0.001 ohm until 0.09 ohm. Repeat the procedure for a value only, set and record all parameters in table 5.5. So basically, we need to set the unknown resistor value from 0.001 ohm until 0.09. Okay, so we need to change this 0. So my group choose 0.002. So here we change to 0.02. Okay, so this is 0.02. So the millivoltmeter has a reading 0.0079 volt. So we need to make sure that we get 0 volt. So we change the resistor. So we get here 996.2 and 998.2. Okay. So here we need to change 996.2 and 998.2. Okay, so when we change the resistor here, we get 0 voltmeter for the millivolt, 0 volt for the millivoltmeter. Okay, so that's all for me. Thank you.